Okay, so this is question 5 from the mock paper from the foundation. It says James is studying the halogens. A website tells James that chlorine boils at minus 35 degrees Celsius and that iodine boils at 184 degrees Celsius. What's the boiling point of bromine? And then you're given 4 options there. Okay, so the way to attack this question is to look at the back of the paper where the periodic table is, and look where bromine is in comparison to the information that you've been given about chlorine there and iodine there. So if we put that information out, it said chlorine boiled at minus 35 degrees Celsius, iodine boils at 184 degrees Celsius. If we show the answers that you're given with next to that, you can see that the only one that fits between minus 35 and 184 is 59 degrees Celsius. Okay, because chlorine and iodine sit either side of bromine, so bromine's in the middle there, you go for the boiling point that's in the middle of the two, which is 59 degrees Celsius. Section B. James tries to bleach small pieces of coloured cloth with solutions of different halogens. Okay, which halogen is likely to make the best bleach? And you've got options of chlorine, bromine and iodine. Okay, so for this you need to know the trend. So look back again at the periodic table. Okay, and here you can see that fluorine, which is the most reactive, is up at the top. Then chlorine is the next most reactive, down to bromine, and then iodine being the least reactive. So if you're looking out of chlorine, bromine and iodine, the one that will react the best is chlorine, and therefore it will bleach the best. So if we look back at the question, our option, or the option we're going to choose, is going to be chlorine, and the reason for that is because it has the greatest reactivity. Section C. James knows that chlorine, bromine and iodine are halogens. Find the halogens in the periodic table at the back of this paper. The relative atomic mass of one halogen is 80. Which one? So this is just gathering the information from the table that we've got on the back. So again, we're looking at the halogens, this group of the periodic table, and we find the one that's got the relative atomic mass of 80. Remember, relative atomic mass is the number at the top of each box, and that highlights it as bromine. Part 2 asks how many protons does chlorine have a chlorine atom have. Okay, so again we're using the information in the periodic table. So back to our table, we're looking for how many protons. The proton number is the bottom of the two numbers. So we're looking in the box for chlorine here. The bottom number is 17, so it's got 17 protons. Part 3. Each chlorine atom has 17 electrons. The electron arrangement is 2, 8, 7 for a chlorine atom. Put crosses on the diagram to show all the electrons in an atom of chlorine. So they give you that there are 2 electrons, then 8 electrons, then 7 electrons in a chlorine atom. Simply a case of filling the shells up from the inside outwards. So you put 2 electrons into this first shell, 8 electrons into this second shell, and then the outer shell is going to have 7 electrons in it. So you can represent that in one of 2 ways. Either you can just spread all of the electrons out, so there's 2 there in the first shell, followed by 8, followed by 7, or you can pair them up, so 2 in the first shell, then 2, 4, 6, 8 in the second shell, 2, 4, 6, and the final one 7 in the third shell there. Part 4. When a chlorine atom reacts with a metal, the chlorine atom becomes charged. use ideas about electrons to explain what sort of charged particle is formed and how the atom turns into a charged particle. Okay, so if we look back at the diagram that you've just drawn, you can see that there are 7 electrons in the outer shell. That means that this electron here is unpaired. There's space for an extra electron to go in there. Okay, and that would take it up to 8 in its outer shell and getting a full outer shell there. So if we do that, okay, if we put the extra electron in, over here, electrons have got a negative charge, so we've got 1 more than we had to start with. So overall, the chloride ion has a negative charge, and that's because it's gained 1 electron. Okay, section 5, chlorine reacts with sodium to make sodium chloride. Fill in the boxes to show a word equation for this reaction. They've given you all the information in the question. It tells you that chlorine, so that's one of your reagents, which is going to go here, reacts with the sodium, so that's going to go into this box here, to make sodium chloride. So that's the product that goes into your final box. So you get sodium plus chlorine makes sodium chloride. Or you could have it the other way around, chlorine plus sodium makes sodium chloride. Part 6 says chlorine also reacts with potassium. What substance is made in this reaction? Well, because they're both in the same group, you'd expect potassium to react with chlorine in the same way as sodium reacts with chlorine. So you'd make potassium chloride. Okay, so you just swap in the name sodium here for potassium here. The answer is potassium chloride.